This question is about chlorine. Give an equation to show how chlorine forms an acidic solution in water. So we need to know that chlorine reacts with water to make HCl and HClO. And that equation balances. Now, they will allow you, if you were to write the reaction of chlorine with water in strong sunlight, you get HCl and oxygen. And if you try to balance that equation with two Cl's there, you'd have to have a half an O2 here. Both of these are acceptable. I prefer the top one. Give an equation for the reaction between chlorine and cold dilute sodium hydroxide. So when these two react, when we're making bleach, we get sodium chloride, sodium chlorate 1 and water. And we need to balance that. In acidic conditions, ClO3 1- ions oxidize to Cl- ions, oxidize Cl- ions to form chlorine. Deduce a half equation for the oxidation of Cl- to Cl2. So the rules say balance the element undergoing redox. If you need to add water and acid, you can do that, but here we only need to add electrons to balance the charge. And then the ClO3- ions to Cl2 balance the chlorine. We'll need to add 6 waters to balance the 6 oxygens on the left, which means we'll need to add 12 hydrogen ions to balance the 12 hydrogens in the 6 waters, and then we'll need 10 electrons to balance the charge because there's already 2 electrons in the 2 chlorate ions. Then we need to join these two together. To do that, we're going to multiply the top one by 5. So we end up with 10 chloride ions and 2 chlorate ions and 12 H pluses. In total, we've got 5 Cl2s in the first equation and an extra one in the second, so 6 Cl2s and 6 waters. Give an equation for the reaction of solid sodium chloride with concentrated sulfuric acid. So you need to remember that chloride ions aren't able to reduce sulfuric acid, so they do an acid-base reaction, and a proton is donated from the sulfuric acid to the chloride ion to give us HCl. And the role of the chloride ion is to accept a proton, and so it is a base, a proton acceptor. Draw the shape of the Cl3- ions. This is a bit tricky. You have to think of it as a chlorine with 2 chlorines around it. So chlorine's in group 7, 2 things attached, so 2 extra electrons, and a -1 means bring an extra electron in. And so we've got a total of 10 electrons, or 5 pairs. But we've only got 2 bond pairs because we've only got 2 Cl's attached to the central one, so we must have 3 lone pairs. Now, when I'm drawing this kind of shape, what I tend to do is use a pencil. I put my central atom and I think, what would 5 pairs do? So 5 pairs would do trigonal bipyramidal, but I've only got 2 bond pairs and I've got 3 lone pairs. Now, if I were to put 3 lone pairs, like here, and here, we can't put them on sticks, but if I was to do that, they'd only be 90 degrees apart. Whereas if I was to put them on the 3 around the equatorial plane, then they're going to be 120 degrees apart. So what I do then is I take my rubber, I rub out my shape, and I change those to 3 lone pairs. And I have my 2 Cl's at the top and the bottom, 180 apart. Chlorine forms an ion with the group 3 element thallium. State and explain the bond angle in this. So if that's in group 3 and we've got 2 extra things added, and then a -1 because a plus charge means we've lost an electron. 3 add 2, take away 1 is 4 electrons, or 2 pairs. 2 pairs and 2 things to attach is 2 bond pairs. So I've got 2 bond pairs and 0 lone pairs. 2 bond pairs repel to get as far apart as possible. And that would be 180 degrees apart. That would be as far apart as 2 bond pairs could get.